Hello, everybody.
Hello, you're welcome, and the stage
Thank
is
you
yours.
so much for inviting me. I'm very excited to present the talk today. So today, thank you so much for the wonderful introduction, Deborah. My name is Paul Azunre, and today I'll be talking to you about some trends in machine learning in Africa, or some trends in machine learning in general, and how we might be able to exploit those trends in Africa and in Ghana. And the organizers of this wonderful conference have asked me to speak to both machine learning broadly, so computer vision and natural language processing, and perhaps ways in which they can be combined. But of course, everybody's perspective on these problems tends to be shaped by their experience. So I think it's important for you to understand my perspective on how I look at these problems. It's important for me to tell you some of my experiences so that you know what shaped that perspective. So as Deborah said, I got my PhD at MIT. Over there, the problem I worked on kind of shaped the way I look at most things. So I was using algorithms to on a very practical engineering problem, which is solar energy. We are trying to reduce the reflection from the solar energy. So we were using optimization algorithms to achieve that, to tell us which specifications of how to build a solar stack in order to achieve some metrics like low reflection. After that experience, I went on to work at Oracle, where I applied algorithms to helping design semiconductors. Again, a very applied engineering problem. And then I moved on to DARPA, where we worked on open source methods for detecting misinformation using machine learning techniques. And of course, that's a natural language processing problem, and this is how I got into NLP and all of that stuff. Right now, I work at a company called Dun & Bradstreet as a director of data science. And what we do there is try to use machine learning to help businesses make decisions, evaluate risk, find customers for their products, and that sort of thing. So to summarize, I'm like an applied machine learning scientist, if you like. One thing that I've been involved in, which I need to mention, is Nlp Ghana. It's an organization I helped co-found, and I'll speak a lot about some of the things we do over there today. And this is a group of more than 100 volunteers now who work on natural language processing for Ghanaian languages and other African languages. Okay, so having said all that, I would like to give you an overview of the talk, or what it's going to look like, breaking it down into 3 sections. One on computer vision. So I'll start with computer vision applications, things I've seen recently that I think are very interesting and that you might be able to exploit. So all the budding entrepreneurs and research scientists in the room may hope to spark some ideas on how we can help some of these things, bringing them into reality and help spark some development. In the second part of the talk, I'll talk about NLP for African languages and Ghanaian languages, as I referred to earlier. And then I'll talk about some cross-model problems. So how do we combine NLP and computer vision, and why we might need to do that? Okay, so a very obvious place to start in terms of computer vision applications that are relevant to us is, of course, in agriculture. And as you know, the availability of data sources available to us has been exploding. So from cell phones that now everybody has, to satellite imagery, and to drones, which used to be very expensive, but now you can buy for a few $100s and set off on your farm, right? So we have all this imagery coming back, and in agriculture, there have been a lot of very exciting applications, and I'm alluding to some of them on this slide, from doing things like building apps to allow farmers to take pictures of their crops, so that then the app can tell them what the disease is, or what disease might be on their plants, so that and then some solutions on how they might be able to solve it, which treatments to buy, to pest identification, and also combining that information with satellite imagery, so that you can map out where people grow various kinds of crops in a region. And once you do that, then you can make plans about how to help them. You can estimate who is going through a tough time, who is impacted by some disease outbreak, right? To things like using drones to detect whether there are weeds on a very large farm. So you can go and remove them. And I do recommend you check out the references on the slide. I'll send out the slides afterwards. And this is when you try to do things like combine satellite imagery with the location of a phone in order to map out where the plants are, or say in a region. Here's an example of the end product result that might be produced by that process. There are very interesting problems that arise, because the location on your phone might not be very accurate, or the people, when they send in the picture, they may not actually be sending it where they do it from, or where the plants are growing. They might go home and send the picture, right? So there are a lot of very interesting challenges that arise in this kind of problem. But as you can see, if you had a map of where the various plants are, let's say in Ghana, where the various crops are, then you could do policy. The government could do policy support and all sorts of things to help improve outcomes. And here again, I'm showing visualization of how you can send out a drone to detect where the weeds are, or where there might be growth issues on your farm, right? So this is very interesting stuff. I strongly believe we are getting to a place where most farmers could be able to afford at least to rent some of these drones. So it's definitely a technology that's become very accessible. And so there's a lot to do here. In fact, if you go to the Zindi platform, of course, is one of the sponsors of our conference today. And if you didn't already know, it's the African Cargo. So you go over there to try some problems. Really, it's a place you can learn about machine learning just by trying problems, very relevant problems that people are interested in today. So people actually have donated money towards specific problems to be solved, which is a very good indicator that that's a problem you need to care about as a machine learning scientist, right? So if you look at the top prizes available today on Zindi, in fact, you will see that the top 3 are all in this category. Using satellite imagery somehow to identify crops or something like that, right? So as a machine learning scientist, you should be aware of this trend. I've also seen a company, a startup in Ghana called Grow For Me, which has actually monetized this idea. So by analyzing the kind of information the farmers send, they're able to vet which farmers are doing well and which farmers are not doing as well. And this enables them to provide funding to the farmers that are doing well, crowdfunding, right, through a platform. So that's a very interesting innovation, not just in the technology, but in the business process, right? So crowdfunding to the farmers that are doing the best, so that we can learn what they're doing and support that, right? So I think that's very interesting. That's a Ghanaian startup already doing this. Of course, applications in agriculture are very interesting, but there are a lot of other ones. Infrastructure, right? So you can send out drones to analyze any type of infrastructure you might be interested in. For instance, power lines, or you may be interested in analyzing railroad tracks, or buildings, very tall buildings. Anything you want to insert in there probably works, right? So this is very interesting. Roads, bridges, right? Places that are very hard and dangerous for people to reach. You can ask drones to inspect that, to know whether we need to fix them. Or you can do things like on the right of the slide, you see a superimposition of the building plan on top of the actual building progress, right? So send out your drone, take the pictures, and then analyze whether you are meeting the specs that you set out for yourself, right? So these are some very obvious, interesting applications of computer vision in infrastructure. And in fact, this came across my LinkedIn a couple of days ago, so I wanted to show it to you. This is from a Ghanaian startup called Epigos AI. And as you can see, they're using drones to detect potholes, right? So send out the drone and find where the potholes are, right? So that then you can go back and fix them. It also tells you how severe the potholes are. So this enables more efficient allocation of resources. So you don't have to go and send out the team to analyze the whole road. You know exactly where the things are, and you can go and fix it and save money, right? So I think this is very cool. And so one of the major things many people will argue behind the explosion in computer vision applications we've seen over the past, let's say decade, has been this idea of transfer learning. So initially, when people started training neural networks for computer vision, ResNets, and so on, they were very expensive to train. In fact, thousands of dollars, right? But if you had to train it from scratch, right? But it turned out that you did not have to train it from scratch every time, that you could reuse a model that was already trained somewhere else in a new scenario, right? And particularly, a data set called ImageNet was invented, which contains more than 14 million images. It contains more than 20,000 categories in it, like cat, dog, flower, and so on. It doesn't cover all categories, but it covers enough that it's a very general data set, so that when you learn a model on that data set, that knowledge becomes applicable to other scenarios, right? So in this case, I'm showing on the slide lung cancer detection, right? So can you say whether there's lung cancer by looking at, the image of the lung, right? So even though in the ImageNet dataset, there was no lungs or cancerous lungs were not included in that, but we were able to take that dataset and fine-tune just a small subset of it. So let's say the green couple of nodes that you see in the slide, just a small number, not the whole thing, just a small subset, and use it in this new scenario to solve a new problem, right? So this idea of transfer learning enables you to save money, enables you to save computes, use less data to achieve results. So many people would argue this is why, or one of the major things that enabled computer vision to explode the way it did. And the thing about now we are transitioning to natural language processing. Natural language processing, on the other hand, even though transfer learning is not a new idea in natural language processing, transfer learning really kind of became more prominent about 3 years ago. And before that, we had models like Word2Vec, which embed text into vector spaces so that you can do computations on them, like turning into numbers. We had models like Word2Vec, in which you were also training on some general data sets and then applying different scenarios, but it was like more rigid and the capabilities were not very strong in certain scenarios. And so, broadly speaking, transfer learning is kind of a newer idea in natural language processing than it is in computer vision. In fact, computer vision in some ways inspired what happened in natural language processing. And in natural language processing, while in computer vision we had this ImageNet data set, in natural language processing, sometime not that long ago, we realized that we could do this simple thing called filling in the blanks, right? Take a corpus, drop some of the words in it, and then try to predict those words back. Right? That's a very easy data set to construct programmatically. You don't have, a human doesn't have to do that, right? Just drop a random number of the words and move on, right? So this data set turns out that teaching a model to perform this task, filling in the blanks, is actually a very general knowledge that becomes very useful in other scenarios, right? And this is the kind of training that is used in models such as BERT, which I'm alluding to on this slide, that you have probably heard about. So this fill in the blanks is like the ImageNet of natural language processing. And once you've done that, then you can fine tune your data set on other tasks. So here I'm showing a list of tasks available in the very important data set called GLUE, General Language Understanding Evaluation, which is a collection of tasks that you might, data for tasks that your model probably needs to be able to do in order to have like some kind of reasoning capability resembling human beings, or that we think are useful, right? So for instance, let's look at what's in the list. Determining whether a sentence is grammatical, right? If I get a sentence, my model should say, oh, this is grammatically correct, or this, or not, right? Or sentiment analysis. Is this a positive sentiment? Is it a negative sentiment? Are these two sentences similar? How similar, right? Are these two sentences paraphrases of each other, right? Does this sentence imply another sentence, right? So this sort of tasks are very important in natural language processing for your model and for various applications. And you are able to transfer the model you learned on the filling in the blanks to this scenario using very little data. So this is an opportunity for me to plug my book, I guess, shameless self-promotion. So I wrote a book on this topic. I first encountered transfer learning at DARPA, where I was using it in kind of detecting misinformation context, broadly speaking. And at the time, this was about 3 years ago, when natural language processing was going through this revolution, let's call it. And at the time, I couldn't find any practical resources or resources that were, building intuition and were focused on the code over, let's say, the theory behind the methods, which is also very important. But because the field was new, I was looking for something that I could just pick up and very quickly start using this method so that I can learn more, right? And this is what, I couldn't find a book like that. This is why I wrote this one. The code that comes with the book is free. So the GitHub link over there, if you follow that, you can just start writing the Kaggle notebooks in like a few minutes. So at no charge. So please take advantage of it. And if it covers the details of some of these methods that I've been alluding to, like in natural language processing, for transfer learning particularly. And just, I guess, to excite you about the sorts of things that are possible with these sorts of methods, here is some output from a model that's very similar to GPT-3. I hope you've heard about GPT-3. It's basically a model, one of these models that was trained to predict words in a sequence the way I was showing you. And then you can use it to like generate poetry or text, or you can teach it to be a chatbot, right? It's a generative text model that has seen a lot of text, and so it's able to generate grammatically correct text. GPT-3 is a paid model right now, so you can't use it for free, but there are alternatives. And here I've put on the slide a link that I would encourage you to put it in your browser right now and try it. It's free. And you can just use it to generate text, right? So right before I came here, I generated this text. I put in the Ghana Data Science Summit is going to be, right? And then I let it speak, right? And I hope you can see that the text is generating. It's very interesting, right? It seems to be grammatically correct. It seems to be making some stuff up, right? So the facts are kind of off. I don't know if there's anything called a Blaze Analytics. It probably made that up. Maybe there is, maybe there isn't. But it looks like it's making some stuff up, but it's grammatically correct, right? So I think it's very interesting that this is even possible today. And I guess I want you to shout out the organization that built the free GPT-3 that I've linked on this slide, called Eluta AI. It's an open source project, so do check them out. Do support open source software. It's very important. And you might have also recently, if you're on Twitter, then you've heard about GitHub Copilot, right? So basically, it's going to write code for you. Before you went to Stack Overflow and you copied your code from Stack Overflow, right? Where you look for some solution and you put it in your code. Now, this is Stack Overflow 2.0. All you have to do is write in the comments what you're trying to do, and GitHub Copilot will go in. It has probably seen code like this before, right? And so it's able to insert or predict what you're trying to do and give you the code that works, right? So there's been a lot of, let's say, noise recently about this tool. Some people are afraid that it's going to take away their jobs, right? Which I guess is a legitimate fear, but I don't think you should worry about that. I think it's something that's going to, if you embrace it and you learn how to use this properly, it's going to make you more effective. That's all. And to give you an advantage over people who refuse to learn new things like this. But I don't think it's going to take your job, because it does not replace a human. If you try it and you look at how it works, at least not yet, right? But there are other issues around this, like the code that it was trained on. Is it copyrighted, right? And it might be. If there's some evidence that it's producing copyrighted code, a code that it should be secret, right? Like keys of various forms. So there are a lot of issues around this technology, but we must admit this is kind of cool, right? And so we should embrace some of these changes and see how we can make them better and how we can take advantage of them. Now, crucially, of course, this is a Ghana Data Science Conference. So crucially for us, it's important to realize that transfer learning doesn't only happen in any one language, right? You can exploit it across languages. So you can do transfer learning across domains. So an example would be, say, sentiment analysis of books versus sentiment analysis of emails. Different domains, right? Models can transfer between them. That's cross-domain or domain adaptation. You can do it across multiple tasks, right? We showed in one of the previous slides how you can teach a model to fill in the blanks and afterwards fine-tune it on, say, sentiment analysis, right? That is multi-task learning or cross-task transfer. Crucially, cross-lingual learning is also a thing, right? So models that we've been looking at, from GitHub Copilot to GPT-3 and everything else, and BERT and so on, a lot of the knowledge that they already have can transfer to the scenarios we care about, and this is why it's exciting. There are risks with that, but it enables a lot of things that otherwise would not be possible, which as engineers we find exciting. So the GPT-3 model I mentioned could be trained to be a chatbot, right? In fact, there's a variation of it called Dialog GPT, which does exactly that from Microsoft. People have already shown that you can fine-tune that model further to generate Yoruba speech, all right? So the models that were trained in English, or for several models, already have some kind of knowledge in them that is useful for Yoruba, that might be useful for Twi or Dagbani or something like that. So this is very crucial for us that transfer learning is cross-lingual. And of course, we talk about NLP a lot, so why do we care about it? So what is the importance to our development of these tools? And quite literally, a life can save lives, right? So in a pandemic, if you can communicate, let's say, best medical practices, you can save lives. Education, if you can provide tools for children to learn stuff in their native language, versus some language that's not theirs and wasn't developed for them and their culture, you could probably improve education outcomes, right? If you can build tools that understand local language, automatic speech recognition, then people who don't have, who are, let's say, not educated and so they don't speak English, can still participate in all the wonderful stuff going on, right? So they can still use computers, for instance, right? If the computers understood their language, right? So it opens up opportunity, opens up growth and development of our society. So this is very serious stuff we should be thinking about. Unfortunately, if you look at most major tools today, let's say Google Translate or any one of those, Microsoft, Yandex, any one of those popular tools, you're not going to find any Ghanaian languages in it. And I mean, even for the African languages included, the African languages included are going to be the very large ones, like Yoruba, maybe, like, Swahili, of course, will be in it just because of the number of speakers, right? But you're not going to see Tree, Fante, you're not going to see any of this, which is kind of sad. As Ghanaians, this is sad for us. And why does that happen? Why is it that all these tools or these platforms just ignore, basically, ignore this huge economic opportunity and group of people? Well, there are a number of them. They don't have training data, right? It's difficult to train models that are very data intensive if there's no training data, right? Training data takes money to produce, but people don't want to fund languages that don't have that many speakers, right? So if and I'll show a reason here, right? These are basically the top languages in Ghana. You can see that the top one, which is basically Akan Tree, is not crossing 10 million speakers, right? Unfortunately, all these funding agencies, when they decide what to fund, they look at impact, right? They may say they want to help or preserve all cultures, but at the end of the day, despite what they say, they're looking for impact because that's how they are also going to be judged at the end of the day. So this just doesn't seem impactful enough, right? So that model doesn't seem to be able to fund the research that we are doing. We don't use these languages not in specialized fields like medicine, so it's hard to even find, even if you had the money and you had the experts, sometimes you don't even know how to say something because we don't use it, we basically forgot what it is. And so it's hard to find the right words sometimes. So the reason I'm bringing this up is I want to highlight that there needs to be an innovation in how we fund this kind of research, and I will speak a little bit to that, what we are trying to do. And this segues into Ghana Nlp, which is the organization that was formed for some of the reasons that were described, right? So volunteers, right? So the volunteers can do some of the work, not all of it. It's not ideal. It's better to pay people, but if you can find enough volunteers, over time you can build something. And this is what we've been able to do. I'll show some things we've accomplished. We build data sets, computational methods, and we're just trying to build the skills, people with skills like this so that they can go out and do stuff like this in the ecosystem. By the way, if you want to join us, the link is right there. If any of this is exciting for you, we'd love more members, more contributors. You can learn a lot of stuff, and we try to make it worthwhile for you. So these are the kind of things that we're doing again: data collection, numerical representation for text, machine translation, speech recognition, and open source tools for deploying those kind of methods. One thing we've done is we've built a corpus of English to Tree, more than 25,000 sentences. You can go and download this right now. It's open source on any of our social media platforms. If you just Google, English Tree dataset Ghana NLP to come up. Check it out. I'll show you some tools we've built using this dataset. The methodology, we combined some, volunteers came in and gave us translations of random sentences that they thought were important, or they use them daily. We got about 1,000 sentences this way. But in order to get to the 25,000 number, we had to augment our manual labeling efforts with some automatic tools. So check translations rather than come up with translations from scratch. And linguists don't like that because it breaks the integrity of the data set. But it enabled us, given our budget, which was basically zero, a few $100s. It enabled us to accomplish this, which would otherwise have taken like 10 times more money to do. These are some examples of corrections and sentences in the data set. We built a translation system. It's an app that's on Google Play now. It's on iOS, Apple. It's called Kaya. It translates Ghanaian languages. We started with Ewega Tree into English and back, right? And then we added recently speech recognition capabilities, and we've also started adding other African languages because our users said, sometimes I have to go to Nigeria and I have to trade, and it would be nice if you had Yoruba in it. So we added Yoruba recently. This is what the interface looks like. There's also a web app. So if you go to translate.ghananlp.org right now, you can start translating things. The web app right now only has text. If you want to use the speech recognition capability, you have to get the app. This is what the interface looks like. It's not perfect, but it's beginning to work better and better. One of the things you can see, if you look down here at the bottom left, you will see that we provide, we open the floor for people to contribute translations if they think it's wrong, right? So if it's wrong, if you think it's wrong, you can contribute a translation, and periodically our analysts analyze the feedback, build a new data set or augment the existing data set, and we repeat the process. And so over time, the system, we find that the system is improving, right? And by the way, we've published a lot of the detail behind how we did this already. And so if you have any questions or if you have any ideas on how we are seeking pilot projects, scenarios that people might find valuable, we're looking to partner with organizations to solve those scenarios. I'll give an example. So recently we made the speech recognition capability available. It currently handles Tree and Yoruba, so you can just talk to your phone, right? And then it will transcribe the tree, and then you can copy the text and use it for whatever you want, whether it's WhatsApp or whatever else you're doing. Again, it's not perfect. Give us feedback if you try and use it. But as you can see, I have recorded a test video or like a demo or a tutorial, if you like. The link is in the slides. We'll send them out. Even I'm not a native speaker, right? It was trained on native speaker speech. I'm not a native speaker, and it gets me a lot of the time, right? So it's very encouraging. I hope you check it out. I mean, this kind of thing opens up a lot of possibilities, right? From using call centers and other things. But a very interesting one that came up recently was just transcribing WhatsApp voice notes, right? We all have that one uncle that doesn't want to type in WhatsApp anymore, right? They want to send you like 10 minutes audio, right? Which, we appreciate it, but, like a certain generation don't want to be listening to audio anymore. They want to read, they want to see, so that in like a few seconds, they can tell what's going on and make a decision whether they want to get into details, right? So wouldn't it be nice if there was a service that we could, whenever our uncle sent us those voice notes, we could just transcribe the tree and then like kind of, be more efficient with analyzing what they're talking about. So we are doing things like that. So like you can upload files or WhatsApp interfaces and so on. In fact, we are working with an organization It's a pilot we're setting up now where we want to see if we can teach kids in their native language first. So teach them how to say things and how to spell things in their native language using a tool like this. So they can say stuff to the device, it will write the word, and they can learn that and see what outcome that has or the impact that has on their education outcomes. So this is very interesting. We hope to speak more about this in the coming months. So earlier I alluded on how do we fund this research, right? So a very important part of all this is we need to think outside of the box and how we fund it. Because I showed you some of the factors why funding it is difficult. So this is one solution we are trying now. It may work, it may not work, we'll see. But basically, the app that I showed you, we want to provide it for free to the community, right? So we hope it's free for everybody to use all the time. We show ads in the free version so that maybe we can, take some of that money and reinvest it in the research and keep improving the tool. So ad revenue. Also, we ask if you use it heavily, we ask that you get a subscription. It's not expensive. It's like $10 a year, right? If you use this heavily and you want to see it survive and exist next year so that you can use it for your work, get a subscription, it will remove the ads. And then all this money is reinvested in the research, 100%. So this is something we're trying. We'll see how it goes. But again, to stress that in this kind of space, you're going to have to think outside of the box on how you fund it, right? So I'm going to very quickly talk about some of this other stuff like word embeddings. This is kind of the way you analyze speech nowadays, right? You need to convert it into numbers. The numbers have to have the right properties. The numbers are vectors, right? So these vector spaces are word embeddings. So for instance, words that are similar in meaning should be closer to each other in this space. So we've started constructing this kind of spaces for tree. This is an example that I'm showing you. And if you look through, like in this case, we're looking for doctor, you will see other words that are related to it will be close to it. And like words like mami are close to words like papa, madamfo, and so on. So this is kind of like a word-to-vec embedding. But word-to-vec embeddings do not understand context. So like a word cell in a sentence like this can mean very different things. Your model has to respond to that. And this is why we built a model called Abana for tree. So in this example, the word so, Okrama no sopa, the dog is very big, right? And then there is so in the other sentence, on the bed, right? On, right? So the word can mean different things, and this model will understand the different contexts and be able to differentiate between them rather than give you one vector every time. And we've open sourced this in a few lines of code, you can use it. So just copy and paste this in your Python, you can start using the model right away. So before I'm coming up to the end of my time, I just wanted to allude a little bit towards this cross-model issue I spoke about before. So we covered computer vision, we covered NLP, and now I want to just briefly talk about this cross-model idea. So a lot of the problems we face today, the really challenging ones, do not only happen in computer vision or text, right, or audio speech, right? They happen like everything is in there, right? So you want to be able to do cross-model analysis, and this is what some of these more recent models such as DALL-E from OpenAI are doing. So DALL-E is a very nice illustration of how text can be associated with pictures, right? So it's learning how to generate pictures from text. And this is an illustration of the fact that even things that were not in the training set, right? So there's nothing like a snail made out of lettuce. Or a snail, what is the next thing is that? A pig made out of lettuce. There's no such thing. And there definitely wasn't in the training data. But when you ask it to generate it, it's able to generalize and come up with some artistic rendition of what it might look like if it did exist, right? So I think that's cool. It's a very vivid illustration of the generalization idea of how you can generalize beyond your training set. But there are applications beyond just this kind of funny artsy things, right, which are also important. But misinformation analysis, right? Nowadays we're going through a pandemic. There's a lot of misinformation out there. Or if you they're trying to inject trackers into our skin, right? Which things that reduce vaccination rates, which harms us all, right? And so we might be interested in detecting when people are lying about this, right? And usually when this disinformation campaigns come out, it's a combination of images, memes, text embedded in images, right? It's no longer just this clean text. There may be text that has to be taken into context together with the image, right? But it's not one or the other, it's the whole thing, right? So this is why cross-model analysis is important. And it's also important in digital marketing, right? Not just misinformation or art, right? Digital marketing. You may be interested in knowing what people say about shoes, right? And if you did something naive in this case, for instance, where you are trying to analyze the sentiment of this picture, and you saw that somebody says pretty sick, right? Which if you just did a key phrase match, you would say, oh, they are probably saying something positive about the shoe. But in fact, if you look at the entire context, it's actually negative, right? So this is an illustration of the fact that you need to take the entire context into account if you want to understand what's happening, right? Not just the text, not just the imagery, but the whole thing put together. And I would like to end with a note of caution. So I've been very hopeful and talking about transfer learning, about how we take these pre-trained models and how we adapt them in new scenarios to this new, very important scenario that are very exciting. There are a lot of risks, and it's very important to be aware of those risks. And a lot of great researchers, an example I'm showing on the screen, have shown all the dangers associated from, the cost of training the models very high, to bias, right? You didn't train the model, so you took it from somewhere. Now you're fine-tuning it in a new scenario. You don't know what it was trained on. Can you guarantee that it doesn't have bias? It doesn't discriminate against Black people. It doesn't discriminate against Muslims, right? How do you know? If you didn't train the model, you don't know what's in it, right? So there are definitely dangers that we need to critically think about, and we need to design our experiments and our tests and the way we evaluate our software, just to control for all these risks, right? At the very least, we need to be aware. It's very challenging. Working in this space is very challenging because sometimes it's choosing between whether you can do something at all with these risks or not, right? So do I do it, or do I, not do it because of the risks? And sometimes it's hard to evaluate what the right decision should be. But we all need to be aware of the dangers. And I think if we are aware of the dangers and we keep working towards solving them, then we definitely will come out ahead. So with that, I would like to come to the end of this talk. And thank you for your time, and ask if there are any questions.
Okay, thank you so much, Dr. Paul, for the wonderful presentation. So we have a few minutes to take some 3 to 4 questions. So the first question says, machine learning has been available for a long time, but seems Ghana is a little behind. What do you think is the reason Ghana is behind, and how can this be changed?
It's a good question. I think the developments usually pretty closely track economic development, right? So our ability to stay in touch with the latest trends in machine learning depend on the health of our economy in general, right? So if you're having economic issues, people have less time and less income to invest with, understanding some of these cutting edge techniques, and you have to invest in education, right? You need to have the latest GPU to even run some of these models, right? So it's all, what I'm saying is all correlated with economic development. How do we change it? Well, I think the government needs to make it a priority. I think there is some positive, I've seen a lot of positive signs that the government is beginning to take these things seriously. I think we can take it even more seriously than we already do. I think we need to step up, especially the private sector needs to step up. At the end of the day, the private sector is going to have to contribute. So people like you and me, like the person who asked the question, and it's up to us. So let's continue trying to innovate, and I think we'll catch up. And this is one of the things that's good about this current set of methods is it democratizes a lot of this stuff. Right now, you can go on Kaggle, get a free GPU for, I don't know, 20, 30 hours a week and run some of the most complicated and most advanced models for free. This is something that a few years ago you couldn't think of, right? You needed thousands of dollars to even be able to run this model, right? Now you can do it for free, right? So a lot of the barriers are lowering, and it's up to us to take advantage of that.
Is that how can we ensure that not only the majority languages are being part of these NLP developments? I am thinking here about being more inclusive and not perpetuating inequalities.
Okay. Yes, we do. This is it is a catch-22, isn't it? So I'm from Bolga, Tanga, right? One of the major drivers I have is to be able to build this Frafra, a language I never learned because I was studying away from my home somewhere else. And so I want to build these tools, but again, I showed you the graphics and I showed you the motivations driving the people funding this work. And if you look at Frafra, it's just not important to them. It's not important to the people funding the work. So if you don't have the money to fund the work, how do you do the work, right? So yes, you are. It's tough. It's tough solving that issue. Innovation in business methods, I think, is the way forward. So our app, for instance, right, it includes Yoruba, it includes Tree. We are working on adding Hausa. We are working on adding Dagbani now. And once we have those, then we can work towards Frafra, right? It's definitely harder, Frafra, Dagari, Sisala, all of those northern languages, right? It's definitely harder to build those models than it is to build, say, a tree model. So for the tree model, at least there's a Jehovah Witness corpus out there, right? So if you're a researcher trying to build, a translation system, and you don't have data to do it, what do? And you have no money to create the data. All you can do is train the tree model, right? What else? In fact, when we first trained the tree model, it was Equapim tree, and people got mad at that. Right? Why is it Equapim? What about Asante, right? Well, that's the data. That's the data I have, right? So there definitely a lot of challenges on how to equitably do this. But I think we need to embed this into our business processes and just form organizations that, let's say, are not just driven by profit, right? So if you are just driven by profit, you are only going to build tools for the largest languages. I mean, if you start trying to do it, you understand why, all right? Because if nobody's using your tool, you don't get paid. So how do you continue doing the work, right? So if it's just the profit motive, that's the outcome, right? But we need some other solutions. We need private organizations partnering with open source organizations, and we need open source organizations. We need contributions from the government. We need contributions from the people, right? So if I'm looking to build a model for some language, let's say Frafra, and I ask the community to help me translate, and nobody comes back and helps me, then what can I do? I have no money. The community is not helping me, right? I have no data. What can I do, right? So all I can do is stop doing the work, right? So all of us can contribute towards making this happen. from government to private, to individuals.
Okay, that's really great. So we take our last question, which is, what is the biggest challenge outside of funding in getting people to work for NLP Ghana?
The biggest challenge.
Yes, outside funding, yes.
Well, I mean, it's for any cross multi-world organization. I think the time differences can be insane. So it's actually what, 3 a.m. here, 4 a.m. Right. So if to get everybody in the same room at the same time can be very tough. And of course, there's a lot of the time innovation happens in those kind of spaces. So I would say that's one of the challenges. And all the other ones I can think about come back to funding. So, I mean, if people had, could focus more, a lot of the people contribute to Ghana NLP have a lot of other things going on, right? So, of course, they go to school, they may even have a job in addition. So, for them to find time to be contributing consistently is tough. And, when they go, somebody else comes in, they have to first learn what the other person did, right? So those kind of things. But I guess those are kind of organizational. Any organization like this is going to face that. But yeah, if you have funding, you can pay people to just focus on this, and then things move ahead. So the things that make it challenging also the things that make it interesting. So I just wanted to leave with a note of positivity. It's cool stuff to be participating in.
Okay, that's really great to hear as well. So thank you so much, Dr. Paul. I mean, it's 3 a.m. at your side, but you made it to come and then give this keynote address. So we are really very grateful for making time to come to talk to us on the current trends and developments in machine learning and AI in Africa.
Thank you for having me. It's been great. And looking forward to a great day of speeches.
Yes, thank you.